Thyssen-Nordseewerke in Emden is one of the major shipyards in the Federal Republic of Germany. The company has 3 building berths for new vessels, 1 dry dock, and 2 floating docks. The Thyssen yard employs close to 4,000 people and averages an annual turnover of more than 400 million Deutschmarks. It is located right in the middle of the large North Sea shipping centers. Building ships for special purposes, both military and civilian, has had a long tradition at Thyssen-Nordseewerke. One example of this is the Barco liner, an entirely new type of ship. It works according to the dock principle. It is lowered like a floating dock to enable the docking and undocking of the barges. In the ports of loading and discharge, the barges, 12 with a carrying capacity of 800 tons each, can be transshipped within 2 hours. Protracted waiting periods are avoided by employing 3 sets of barges, 1 set each in the ports of loading and discharge, while the 3rd set travels continually on the Barco liner. The containers, a maximum of 500, are handled by the ship's own gantry crane. In the summer of 1979, the first Barco liner left the port of Bremen on its maiden voyage to the Nigerian capital of Lagos. In 1978, the Thyssen yard celebrated its 75th anniversary. In 1903, the company was entered into the commercial register with a share capital of 2.1 million Goldmarks. In 1911, Kaiser Wilhelm II coined the phrase, "Germany's future lies on the seas." The country's general economic upsurge led also to a rapid expansion of the Nordseewerke shipyard. The company's tradition of special shipbuilding began during the First World War and was continued during the years of World War II. Until 1945, 30 submarines were launched at Emden. The 60s and 70s brought new significant orders for special naval vessels. First, 15 submarines were built for the Royal Norwegian Navy, then another 10 for the West German Navy. These 25 submarines are a significant contribution to the naval defense potential of the 2 countries. During naval maneuvers of the NATO Defense Alliance, these submarines have proved to be most reliable and effective. The company's expertise in specialized shipbuilding became the decisive factor for concluding a contract with the Argentinian government. Since 1978, the yard has been engaged in the design and construction of the TR-1700 prototype for the Republic of Argentina. The TR-1700 submarine is characterized by great diving depth, an extensive operating range at economic speeds, its worldwide employment potential, and excellent maneuverability. Because of its high top speed, the TR-1700 submarine is capable of pursuing even fast-moving targets. This enables the ship to catch up with an enemy even from disadvantageous starting positions. The TR-1700 carries highly sophisticated equipment. Its components are supplied by the leading manufacturers of the Western world and meet the most exacting requirements of modern naval warfare. To ease the extraordinary strain of long missions, a high degree of living comfort is provided for the crew. The officers' cabins, the cabins for the chief petty officers, the crew's accommodations, The messes, the galley, and the sanitary facilities offer extraordinary comfort in a confined space. The submarine forms the basis for a sophisticated weapons system super-sensitive sensors, the fire control system, and the wire-guided torpedoes. The surface sensors consist of periscopes, radar system, and ESM system. The data from these devices, used only while the submarine is surfaced or submerged at periscope depth, are gathered in the Combat Information Center. With these surface sensors, it is possible to detect, locate, and recognize surface ships, aircraft, and helicopters. Still more important are the underwater sensors, the sonar systems. The main sonar system operates both in the active and passive modes. In the passive mode, it can receive noises emitted by surface ships or submarines and thus locate these vessels even at great distances. Sound waves emitted in the active mode can, by means of reflection, detect objects that do not produce any noise of their own. All target data are fed into the fire control computer, which evaluates the target bearings by means of a sophisticated digital computing system and freely programmable processors, and transmits the target data to the weapons. The fire control system is capable of tracking and engaging several targets simultaneously with a very high hit probability. The torpedoes are housed ready to be fired in 6 torpedo tubes. The torpedo tubes are designed according to the swim-out principle, which means that the torpedoes leave the tubes self-propelled. The fighting power of the submarine is considerably increased by the reserve torpedoes housed in the torpedo store. A hydraulic mechanical system enables a rapid reloading of the tubes. The TR-1700 has a rescue system which allows to save the lives of a trapped submarine crew in a great number of conceivable emergencies. A pressure-proof bulkhead divides the submarine into 2 compartments, each allowing the crew to survive for up to 7 days, until they can be picked up by a rescue submarine, such as the DSRV of the U.S. Navy. In depths of up to 150 meters, the crew can leave the submarine in small groups through the diver's lock. At depths of up to about 100 meters, the compartments can be flooded. Once pressure equalization has been attained, the crew members leave the boat in quick succession and climb aboard the life rafts released from the submarine before. Another safety feature is the hydrazine system. In case of a danger situation, such as the jamming of the hydroplanes, the submarine can be surfaced by blowing the ballast tanks instantaneously. The planning, design, and the building of a prototype for a new naval vessel require creativity, genuine teamwork, and particularly exact timing. A whole staff of engineers, technicians, and draftsmen spends months in the elaboration of the project. From the first line on the drawing board to the day of the sea trial, every design and construction detail is fixed in a critical path diagram. The ship is divided up into clearly delineated production units. Sectional building plays a major role in such projects. This production method requires a maximum of coordination because several different workshops are involved in the construction and pre-outfitting of the sections. Apart from the typical shipbuilding processes, there is a large number of pipes, foundations, machines, generators, ladders, covers, and other components that have to be built into the sections. The first step from the design to the construction phase is taken with the aid of electronic data processing. The design data of the ship have been changed into computer language and stored on magnetic tape. This data bank forms the basis for the further elaboration of the production process. Every single part of the ship's hull is coded and skillful arrangement combines several different parts on one single plate for the flame cutting. A punching unit connected to the computer turns the total of data and information into a perforated tape which controls the flame cutting machine. To check the control tape, a numerically controlled drawing machine produces an outline of all pieces to be cut from one plate. Parallel with the planning and design work, a model of the TR-1700 submarine on a scale of 1 to 5 is built in Noordzeewerke's model workshop. This model, easily dismantled, reveals important details of construction, assembly, and design. Before the start of production, the materials are made available. Plates and profiles, mostly made of high-tensile HY80 steel, are supplied by a Thyssen company from the Ruhr area and stored in the plate and profile store. Before their use, all plates and profiles must be shot blasted primed, and marked. After arrival in the flame cutting hall, the plates are marked and cut by numerically controlled flame cutting machines. Then the welding joints are prepared, holes, cutouts, and shaping cuts are made true to gauge. The pressure hull plates are pre-shaped by hydraulic presses and then cold rolled to measure on a bending roll. Elsewhere, the frames are put together. A frame consists of several flange and web plate segments which are welded together. The flanges are rolled from flat steel. The webs are flame cut from plates. For the assembly of the frame, The segments are placed into a tack and assembly jig and tack welded. Mounting of the restraining elements to the first annular frame. Compasses are used to check the circularity. The seam is prepared. Then wet plate and flange are welded together. This kind of work requires particularly experienced, specially trained welders. Several frames and the corresponding pressure hull plates form a subsection. The treatment of the pressure hull plates and the fabrication of the frames are followed by the fabrication of the subsections, a highly complex part of the production. The pressure hull plates are aligned, tack welded, and preheated. Now follows the welding of the seams. The root layer is ground and all the welds are inspected with testing equipment. Several subsections form a section, in which also parts of other structures are incorporated. The restraining devices and the staging have to be removed. The components are placed on slewing mechanisms, enabling them to be turned into an optimal working position. Walls, decks, bulkheads, and tanks, as well as the supports for engines and aggregates, are assembled individually and incorporated into the section. The battery compartments are assembled to form large boxes and then fitted into the section in blocks. For the installation of cable and pipe supports, special automatic welding machines are used. The pressure-resistant transverse bulkhead is also built separately and then fitted into the section. Manufacture and assembly of this bulkhead are extremely complicated. The transverse bulkhead serves to divide the submarine into two watertight compartments. Special care has to be taken when drilling holes for the lead-through of cables and pipes. All materials and processes are tested in the testing laboratory. To prove the tensile strength of welded connections, sample pieces are subjected to tests that go far beyond their expected yield values. For the manufacture of the pressure-resistant parts, such as the pressure hull, bulkhead, axis shaft, and torpedo hatch, preference is given to steel with high tensile strength and notch toughness. One example is the heat-treatable HY80 steel, developed especially for the manufacture of submarines. In the presence of the Commander-in-Chief of the Argentinian Navy, the keel laying of the first section of the TR-1700 prototype was celebrated in a short ceremony at the Thyssen shipyard. Now begins the actual assembly of the submarine. All the sections together finally form the pressure hull. The sections are assembled in a hall for which special security measures have been adopted. This is also where the pressure-resistant reinforced axis shaft is built. The bow section of the boat is equipped with the torpedo tubes. Part of this section is a spherical bulkhead, the forward ceiling of the pressure hull. This bulkhead is penetrated by the 6 torpedo tubes, arranged in 2 rows, one above the other. Sealed with heavy, forged covers, they will later house the torpedoes, ready to be fired. While the submarine is underway, this forward section is flooded with water. The assembly of the course-keeping and depth-keeping rudders is a complex process and requires specific templates. For the pressure hull penetrations, special reinforcements are made and welded into position. Slewing mechanisms, each section can be brought into an optimal position for the boring of the penetrations. A transportable boring machine is accurately aligned and then carefully starts taking off chip after chip. For the passive sonar systems, windows are milled into the sidewall steel plating and later covered with fiberglass reinforced plastic plates. The noise level of a submarine has to be kept as low as possible. For this purpose, engines and generators are supported by special foundations of layered steel and rubber elements. These elements act also as effective shock absorbers. Prior to the installation of the engines in the engine room, the elastic elements are carefully fitted into their exact positions. Diesel generator groups are installed with the aid of a crane and special supporting structures. Most connections in the seawater exposed sections of the submarine are made of copper-nickel alloys, which have proved to be resistant to both seawater and wear and tear. All sections are sandblasted and coated with primer. A heavy-duty lifting truck transports the aft section of the submarine from the sandblasting hall to the assembly hall. During the entire building period, all the components are securely and safely stored on supporting and transport foundations. Knowing the exact weight of the submarine is extremely important for the hydromechanical calculations. In order to match the design values, each individual section has to be weighed. This is accomplished by 4 electromechanical pressure cells. Any component which is installed later also has to be weighed exactly. Meanwhile, all individual sections have arrived in the assembly hall. While the outfitting and installation work is progressing at a lively pace, The welders are joining the first connecting seams. Of the submarine requires a floating dock capable of satisfying all the requirements as to trimming capability, pumping capacity,